When you buy something or rent something, like from Netflix, there are no human beings who are spooling up digital videos for you. It's all done fully automatically. And we, at UCSB, where I was a researcher before we started Eucalyptus, we spent a lot of time studying what was different about this as an infrastructure model, right? Because this model's been around for a long time for selling people things, small things, that are usually delivered by UPS. What was new is that we were going to use virtualization to rent in the way that we rent movies or other temporary content, but using the same infrastructure that we've used all along. So we, as researchers, were very interested in studying this, and what we wound up doing was building a very similar set of web services that doesn't necessarily run in a Google-sized data center, but is in fact designed to run in your data center, or in any data center, right? So this is much more typical of what one sees at the enterprise level. It's heterogeneous. There's different kinds of machines typically, and that's because the hardware and software life cycles vary. You bought this 3 years ago, you bought this 2 years ago, you bought this last year, if that's your compute refresh cycle. There are people in the loop, right, in the enterprise. These people are very important. They maintain the infrastructure, they maintain the software, so on and so forth. But the same transactional web service e-commerce style access is attractive. We know how that works. It's familiar. And the technologies for building this are very mature, right? We've been building these scalable websites for 15 or 20 years now. So an enterprise cloud is really the same model for accessing resources, but where the back end is not a purpose-built data center for e-commerce, but in fact enterprise grade technology. This is sort of the summary of that. A couple of other things to note, if you think about this as an e-commerce model, you're really much more worried about site integrity and site availability in a cloud than you are necessarily about individual transactions, right? If you think about it, if I'm trying to buy a book, and that book just, the book transaction or the book purchase fails, my assumption is the user will retry. There isn't a callback, right? There isn't a log that says, oh, Rich just tried to kill a mockingbird, and that purchase failed. It's, I'm going to retry. And it's okay for the site in response to fluctuating demand or network connectivity that is changing, to occasionally drop individual transactions, as long as it drops them transactionally, as long as I don't take your credit card and charge you and then not send you the book. So you really have to think about transactional access and site integrity. Customer requests must be isolated. It cannot be the case that when I try to buy To Kill a Mockingbird, I can prevent you from renting your favorite video from Amazon's video service. Right? So there's this isolation property, which is essentially that the site must serve competitive needs simultaneously. And then there's really two kinds of scale. We hear about scale out, and this is the idea that you're going to add resources to the platform, and you scale out for request volume. As users join your system, or as more and more users begin issuing requests, you need more and more resources, and that's because the user requests are isolated. And you must scale up with request weight. Not all requests of a cloud carry the same weight. If you are asking for things that are heavyweight, that require more computation, then you need to devote more cores, more memory, more disk to them. So you need to be able to scale out for user requests and scale up for request weight. What does the architecture then look like for this? What I've really described as the origins is infrastructure as a service, right? Which is the notion that we're going to virtualize what looks like a piece of a data center and then serve it over the net, over the web. And then there are lots of higher level services, just like there are in any data center, that need to run on top of this to make it truly useful, right? So there's a management platform, something that uses this API, which is very scalable and follows that model, and we know how to build these kinds of things because we've built them for many years, to control either VM containers, the idea that you're going to stand up and tear down collections of VMs that may or may not be coordinating with each other, and various other platforms that are either language specific or binding specific. So Google App Engine, this is a platform for running Python and Java, right? It has special bindings for Bigtable. It runs essentially on an infrastructure as a service mechanism, and there's an open source version of this called AppScale, which runs on our platform. MapReduce, MapReduce is a great distributed computing paradigm. It's essentially what we used to call an out-of-core server in the HPC space. Hadoop is the open source version of it. It runs on infrastructure as a service. It needs to be able to spin up VMs and attach network addresses and do things with volumes, just like these other things can. And then we're starting to see other platforms, Ruby platforms, PHP platforms, Java, platform as a service. You hear this coming about. And all of this can be managed through the infrastructure as a service by a management layer. So what I want to talk to you today about is Eucalyptus as an open source infrastructure as a service layer, and RightScale as being the management platform that uses this in the enterprise to control these stacks. And the Lucky Charms things up here are really designed to be or represent the application components that run in these various environments. Okay, so you know about RightScale, and we'll get back to how they work together. What I thought I would do is talk a little bit about Eucalyptus. Eucalyptus started as a research project in 2007. It was an early research project in cloud computing, the University of California, Santa Barbara. And if you've not been to see our friends at RightScale in Santa Barbara is infested with eucalyptus trees. And one of the engineers, then a postdoc in my group, who's a photographer, was really annoyed by this because he couldn't take pictures of the coast. And so one day he came back and he said, you know, Rich, we need to call this project Eucalyptus. And I said, only if we can name it as an acronym. And he said, you can't name this as an acronym. It is, in fact, an acronym, Elastic Utility Computing Architecture Linking Your Programs to Useful Systems. It's built entirely out of open source web service components, funded by the NSF originally, and one of the key differentiating factors we know now, but we did not know at the time, of Eucalyptus is it will function as a software overlay, which means we don't go into a data center, an enterprise data center, and say, okay, all this equipment that you've spent 20 years building, throw that out, put in some new equipment and run Eucalyptus on it. We will run Eucalyptus on what is there. And that's because in an academic environment, I absolutely cannot modify anything that I want to run my research infrastructure on. Nothing. I can go to a data center that's managed by the chemistry department and ask them to run something on top of what's there, but it has to take into account everything that's there. It has to take into account the hardware platforms, the configuration, the security policies, and not modify them, or they won't run my software. So this has actually permeated over into the commercialization of this technology, and it turns out to be incredibly useful. And then we also are we're faced with the problem of running on different versions of Linux because, of course, if you're doing this for the National Science Foundation, every supercomputer center, every university data center, every DOE research lab runs a different version of Linux at a different rev level, and you want them all to run this stuff. So that was our original idea, and we really were interested initially in stimulating interest in cloud computing. We thought if there was a platform out there, it would act to dampen the hype. Right? We thought, okay, we're going to give you the actual source code to a cloud, the actual source code. And this doesn't seem to have been effective, but that was our idea, is that we would demystify cloud computing. And we really wanted to build this from first principles. We thought, okay, there's a lot of grid technology. I've worked in grid computing for a long time. There's a lot of SOA technology. There's data center virtualization technology, which is still with us. And all of these things were suddenly clouds. And we thought, you know, all of those have some aspects of clouds in them, but what was really unique about this was that combination of e-commerce technology, e-commerce style access. And so we thought, we're just going to build this from scratch, so we don't carry forward any of the sort of baggage that these other technologies have, because they were architected for different purposes. We built it from open source, and this is good news. The best open source technologies in the world for e-commerce are available. J2EE, JBoss, MySQL, Spring, Mule, all these kinds of things have been around for a long time. They're very robust. Lots of businesses run scalable services on them. As I said, it runs on existing infrastructure without modification. Now, another issue that we were faced with very early on was the issue of API. And we originally designed our own API for this. We thought, yeah, we know how to do this. And as researchers, we then went out to try and interest the community in our cloud. And we would write grants or write papers or give talks and say, you know, we've built a cloud. And they'd say, no, you haven't, right? Your cloud is not compatible with my cloud, and I've built a cloud. So by definition, your thing is not a cloud. And you know, you can sort of do this as academics for a while, but at some point we got tired of that argument and we said, well, look, okay, everybody in the world in, say, 2008 agreed that Amazon's AWS was a cloud, right? No matter what we were all saying to each other, we all said, you know, it's sort of like Amazon AWS. And we said, okay, well, we're gonna do the following thing. We're gonna bolt an API onto this platform, which is agnostic to API, that is so compatible with AWS, nothing will be able to tell the difference between it and AWS. In computer science terms, this is called a Turing test, after Alan Turing. Right? We conducted a Turing test for cloud using the AWS API, and RightScale was our tester. We called up our friends at RightScale, who are in Santa Barbara, and we said, we need you to do this Turing test for us. Will you point RightScale at our Eucalyptus cloud and see if it will work? It worked on the first try. So the AWS API for us was a way of silencing the argument over whether what we had built from first principles, from e-commerce technology, is a cloud. It is. And, but that's also persisted with us because it also happens to be the #1 API for applications today. We didn't know that at the time. I'd like to say we could have foreseen that. We didn't. So this is the architecture of Eucalyptus. There is an API translator. For the moment, the only thing we ship is AWS. We've done 4 other APIs for it over time. We just don't do the QA on them, and there's really no user community for the others. So, so that's what we've got going today. It bifurcates into the EC2 side and the S3 side, which is called Walrus for sleepless academic reasons. It was very late at night, and a walrus somehow factored into what we were naming that system. We did this in version 1.3. The first version was just EC2. Sorry? No, unfortunately not. It has to do with someone had this mascot, which was really a sea lion, but we called it a walrus, and yeah, who knows. As I said, these things take on a life of their own, and it's 4 o'clock in the morning, and we're trying to get release 1.3 out by Thanksgiving, and it's walrus, right? So we're on Eucalyptus 3.0 now, just to give you some idea. This is basically 2008. We're doing all this stuff at the university, but yeah. So there's EC2 and S3. And it's a 3-tiered architecture. This is the state machine for managing user requests. It's very transactional. It uses every e-commerce web transaction trick in the book. Optimistic database commit, aggregated transactions, rollback, you know, fast locks, slow locks, all the tricks in Java that you can possibly imagine for memory management. The guys who built this came back to academia after working in web service e-commerce stuff for about 10 years. So they really said, look, we know how to build that. And then the bottom end is written actually in web services but in C, and that's for memory footprint. And it consists of 2 layers. There's a scheduling and sort of capacity planning layer, which is we call the cluster layer, and then there's the hypervisor layer. And we support VMware's vSphere, so we can talk to vSphere, which then talks to a bunch of hypervisors, which are ESX or ESXi in the VMware world, or we can talk directly to the hypervisors themselves. We can talk to other management platforms. So far, the one we have working in prototype form is RevM, although we are planning others here because almost all the hypervisor manufacturers are building some sort of service layer now. And then the original version would talk to Zen, and we still support this, Zen or KVM directly on the nodes as long as they're Linux nodes. We do S3, and then we do also Elastic Block Store per availability zone. You can put these, you can aggregate these things into availability zones, and there's a storage controller per availability zone. And the only thing that's a little bit weird, if you're a tiered web service person, is the database is at the top and not at the bottom. And that's because in this business, you really want to hit the database when you're interacting with the user and then allow delivery to be asynchronous. So you can think of this as really the e-commerce piece, and this is the UPS piece, or the FedEx piece that's actually delivering you the service asynchronously. It uses eventual consistency, so it's very, very scalable. It doesn't use callbacks. There are no global operations in the node fields, this kind of thing. So it's designed for scale. Okay, so what I wanted to do here is talk a little bit about why infrastructure as a service so far has been the cloud model of choice. Right? There's infrastructure as a service, there's platform as a service, which we're starting to hear something about in terms of excitement, but not really in terms of usage, and then there's software as a service, which everybody loves. But really in the cloud model, the infrastructure as a service so far is the dominant paradigm. And the reason is because of several factors. The first is an application today is really multiple technologies, right? If you go and look at a 3-tiered web service, you've got Apache, you've got Tomcat, probably have Memcached, MySQL, PHP. You know, you've got several different technologies, and they're all stitched together. They have to be stitched together through their configuration primarily, right, to form this application. And there's no isolation between them without a cloud. When you stand these things up, they don't have firewalls between them. You know, if one eats up all the memory, it takes the memory away from another. 3-tiered architectures without the isolation support of cloud computing can be tricky, right? So this multi-technology idea, the idea to be able to combine technologies dynamically at runtime, is something that infrastructure as a service makes possible. You put them in different VMs. The VMs are isolation containers, and the interaction is very controlled. Legacy support is a second reason. It's absolutely the case that you want to be able to run a stable version of an application over a period of time that spans the time that the software it's using is stable. In other words, I get the application working with a set of system libraries and an operating system, and I don't want to freeze that moment in time. This is particularly true for Java, right? Every 20 seconds, someone changes a Java library. And there are millions of lines of Java library code that a small Java program typically accesses. When those changes occur, you have to go through a full QA cycle if you really want to be right about your software. Or you get it working, you get all the revs there, and you take a snapshot. And the nice thing about the cloud is that snapshot will stand up in 5 years and work. You may not like the security revs, it may be old library technology, maybe Python 3 or something like that, but as long as that's all embedded in those virtual machines, they'll all work, because you're now capturing the entire environment that the application runs in. Everything, all the bits the application needs, including the source code that you've written. So you can run legacies alongside new code, you can roll out new versions and old versions at the same time and flex how much of each depending on how well your new version is doing, et cetera, et cetera, et cetera. Another reason that infrastructure as a service has turned out to be so immensely popular is transparency, right? You've got this image now, it's isolated. You can give root to the application programmer. That's often very, very useful. I know it sounds crazy, but it's crazy if the application programmer can go around and hack on everybody else's password. The application programmer can only live within the application programmer's sandbox. You're much more likely to allow them to install software, to fool with the configuration, to change the DNS settings or whatever it is. And they can see inside for debugging purposes, and your IT people can see inside for debugging purposes to figure out what's going on. So this transparency is really, really useful. You can attach QoS to these containers. It's kind of a bludgeon. It's a big container, but you can say, this one gets a lot of memory and this one doesn't. And it's the same software. Notice that QoS is in the container. I can take, an Apache server and I can give it 2 gigabytes of memory or 500 megabytes of memory. It's the same Apache server. You might get different qualities of service out of those two deployments, and so you can attach QoS to the container itself rather than to the application. And lastly, it's anti-lock-in. And here, if this virtualization, this cloud hype, whatever, doesn't work, if this is not the next coming of infrastructure or whatever, these are images that will run on your bare metal. You can back up. All you've done is prepared something that an automatic tool can move around for you. If you want to do it manually, you can. So infrastructure as a service is really where it's at today, and this is why. But it's not all roses and champagne. The first thing that happens with infrastructure as a service is you're trying to do this zero touch, which means you don't want the IT people in the loop, which means applications programmers are trying to do system administration, which is difficult. Right? It's not always the case that you can depend on an application programmer to know what version of Python they need, or to know what configuration problem there is. So you've sort of outsourced the problem of configuration management to the application programmer, and somebody in that outsourcing, either the programmer themselves or someone who is assigned to work with them, must understand that configuration problem and how to do dynamic resource provisioning. Second thing is that you're really working with a big blob if you're doing QoS optimization, right? You get to assign QoS to the container, but you may want to assign QoS to pieces that are inside the container. You can break them up into separate pieces, but now you have this decomposition problem, which might be equally complicated. So this is good, but not great. And lastly, heterogeneity, the idea that you're working with lots of different technologies at lots of different rev levels is a great thing. It's very powerful. You can really do great cost optimization by zeroing in on exactly what you want in multi-technology, but it's hard. Right? Now you have interactions not only between different hardware and software packages, but at different rev levels. And if you've ever worked with Linux, especially Ubuntu 9.04 is nothing like Ubuntu 10.04. They're both Ubuntu Linux, but God help you if you try to combine libraries from both, because they are really, really different. So there's this heterogeneity problem. Fortunately, RightScale is the solution to these problems. These are the drawbacks, but RightScale gives you this just absolutely beautiful environment for managing all of these problems. And that's why we love working with them. Okay, so I promised to talk about hybrid clouds. And hybrid clouds today exist. Eucalyptus has a very faithful implementation of the AWS API. So you can move images, data, firewall rules, all of that scripting back and forth between Eucalyptus and AWS at will. It works today. And you think, wow, this is cool. I have one cloud. I take Eucalyptus and AWS. Well, not exactly. You do have one cloud at the technology level. We make the bits look the same. So the same bits work in both places. But as Torsten van Eycken, who the founder and CTO of RightScale has pointed out, you might use a different model for developing in a public cloud than a private cloud. Torsten's idea, he calls roll forward, which is to say, in a public cloud, when your application is doing something, failing, hopefully not, or expanding its footprint, or slowing down because of load, what you do is you simply add new resources. Right? You don't try to defend it against failures. You don't try to defend it against denial of service attacks. You just allow the problems to happen, and as they happen, you spin up new pieces of your application, and you tear down the old ones. You have to code for this. It's very stateless. But once you've coded for it, you use this model of always acquiring something new, and then you garbage collect what you don't need. That works great in a public cloud. You're limited to 20 instances by default in Amazon. Within that 20 instance limit, you're free to sort of expand and contract at will, and if you can code to this model, it's wonderful. In private clouds, though, it's a little different. In private clouds, you need quotas, because the resources are much more finite. And people have rights. They have rights to certain fractions because of the budgets that, of the data center. And so the private cloud must be able to respect those rights and must be able to communicate when you're getting close to the edge of what's necessary. And even if there's extra capacity someplace else, you have to think very, very hard about how you can loan that capacity within your accounting system, or accounting model, to others who need it. So you have a much more access control focused development approach. And what you have to be able to do to build a hybrid application is live in both of these worlds. It's the same code. It just uses two different models of deployment. And so this is one of the interesting problems that RightScale solves today. So what does a hybrid look like? Well, this is a cartoon. I only can do cartoons. This is supposed to be AWS, Amazon.com, and RightScale runs in AWS. It is a set of images. It uses all of the AWS facilities, the AWS API. But what it can do is it can reach out across the internet and control Eucalyptus as if it's controlling AWS itself. It's just using the API. All it needs are the IP addresses for the context strings, right? So when you run RightScale, it manages your VMs by talking through the API with IP addresses to AWS, and then it can do exactly the same thing with Eucalyptus by changing the target IP addresses and sometimes the ports. So this is a very powerful architecture. Right? This is wonderful because you have the access to the public clouds, and without any change, access to Eucalyptus running in your data center. The reason, though, that you want to do this, because a lot of people look at that and they go, oh, wait, Rich, come on now. The data, what if my data goes over here? Okay, you have to control that. You have to be careful about where the data goes. Or there's failure possibilities, or isn't this insecure, all these kinds of things. There are ways around these tricks. But here's the reason that hybrids really make sense right now. This is due to Phil Papadopoulos, a friend of mine and a researcher at San Diego Supercomputer Center. He did a survey of the number of free images inside Amazon's AWS today. Now, he did the survey on September 7th, and he did it again in green on December 30th. It's 6 months later. I don't have more current data for you. Almost 8,000 free images in December. probably north of 9,000 today, if you look at that growth curve. What does this mean? This means that there are 9,000 fully QA'd packages, fully QA'd Linux installations that have just about everything you can think. Different versions, there's Windows, some that I've never even heard of, so on and so forth. All of that stuff is running constantly in Amazon, constantly subjected to QA. You can download these and run them in Eucalyptus today. This is a lot of free software. There are 4 Linux distros that you care about. This is bigger than 4. And in fact, it's 3 commands, right? These are the 3 commands that you have to issue in order to upload. Don't, right? These are ugly. This is not what you should be doing. You should be doing this, right? That's the reason. This works. The baseline plumbing works. You get access to all that stuff, but you should be doing it with something that is much nicer to use. We make our sales engineers do that. And then, once you've got the images, that's the ecosystem that you get along with it. That is a subset of the 140 partners Eucalyptus has today. These are companies, projects, people who are generating software, systems integrators, consulting firms, a whole ecosystem, in addition to those free images, that have signed up to work with Eucalyptus. There's a lot of other people who work with Eucalyptus without talking to us. RightScale, of course, being the most central of those who have signed up. But we have, through the AWS compatibility, a vast ecosystem of tools and of other services that are available with Eucalyptus. Now, about 6 weeks ago, Amazon was running along happily, and someone changed a routing table inside Amazon, and EBS broke. And it broke for all sorts of interesting reasons, and those of us who study distributed systems were writing these erudite analyses of the problem. But the bottom line is, because this is a fully on-premise cloud, because Eucalyptus runs over here, the AWS APIs work with Eucalyptus even when things don't go so well. If you have an issue, right, with your public cloud, you can still run inside Eucalyptus. The other thing that happens occasionally is that while this stays up and this stays up, that connection can be problematic. And again, in this case, your RightScale stuff works. Eucalyptus continues to work. It's not great. You're resorting to talking to Eucalyptus directly as opposed to using the single pane of glass, which is by far the best way to do it. But you have a backup plan, right? You have access to free software. You have access to this huge ecosystem, and there's a backup plan. And it's really important to understand that this thing will run in completely disconnected mode, right? Not all clouds are prepared to do that. Okay, so with RightScale and Eucalyptus, in my cloud, sorry, you can tell I'm really into the word thing. Hybrid compatibility. We are AWS compatible. RightScale sees the same API when it talks to us and AWS. Image Ecosystem is huge, free software, runs in RightScale with Eucalyptus, lots and lots of choices, huge partner ecosystem, and it runs standalone so that you won't be left with a bad network connection wiping out your system. And we're very, very happy that it works with RightScale. Okay. So what I thought I would do as a way of summing up is to talk a little bit about the question of whether open source is the right strategy. Hopefully I have covered the idea that the architecture is the right architecture, that we have the right model, that we're working with the right partner in RightScale. Now the question is should this be open source? Now for most people who are planning on putting in a private cloud, the answer is yes, it's open source, it's going to be free. Well, maybe. Free is one of open source's misguided characteristics. Nothing is free, right? Particularly in infrastructure. It's cost effective, certainly. But there are a lot of good reasons that Linux as an operating system platform completely wiped out Unix in about 5 years. Right? Here are the reasons, right? Because in about 1995, I was doing data centers, and we didn't do Linux, we did Unix. We did lots of different versions of proprietary Unix with lots of stacks. AIX had everything all the way up to the eyeballs. You can get CICS for AIX, right? And it's all gone. It's all gone in 5 years. Here's why. First off, Linux is extremely hardware portable. Most versions of Unix are not. You can disconnect the hardware lifecycle from your operating system lifecycle. Very important. If you get a deal at a Dell next week and you want to put those Dell boxes in there, they're going to run Linux. And the porting effort doesn't exist, right? It's already been done. So open source gives you access to tremendous hardware portability for commodities. And that gives you a lifecycle management thing, and it prevents lock-in. You're not locked into one vendor. Ecosystem. Linux is interesting. There are probably about 25 or 30 people who contribute to the Linux kernel. There's probably 2.5 million people who build software that run on Linux. The ecosystem you need to care about in terms of contributions is what will run on the platform, but the platform has to be open and transparent and readily available to anyone, at least in some sort of mode, for free, right? So this ecosystem of software completely wiped out what any legitimate tech company could provide on the same time frame, and everybody is doing QA on this. Everybody. We see so many people who are feeding back problems, issues, complaints, thoughts for the open source Eucalyptus. It really speeds our QA process, and that's been true for Linux for a long time. It's transparent. When something goes wrong, you can look inside. And absolutely, if you have a problem, if you really get up against it, and you need someone to go in and hack a device driver, or do something with the memory management system, or tweak the scheduler, you can do it. I don't recommend doing this in the kernel. It's not for the faint-hearted, but I've actually seen customers who, to get themselves out of a bind, will do it, and that is not possible. It's not possible with proprietary software. On the other side of the spectrum, it's extremely fast to remediate. So, if you have a problem with a disk driver in a proprietary version of Unix today, you're going to call up your representative. You've got a 4-hour SLA. They get back to you in 2 days, and they tell you, we're going to have you a fix. It's coming. Watch one of your system administrators remediate a disk driver problem today. It takes 2 minutes. They type in the disk driver model to Google. 100 hits come back saying, I've had this problem before, here's how you fix it. This is what administrators like. They don't have to call anybody, and Google is the manual. So when you have a problem, it's very fast to remediate. And enterprises absolutely love this. And last but not least, there's a free version. You can just take it down off a website someplace, and if you have enough in-house expertise, you can get it running. It's not clear you can get it running at an enterprise quality. For enterprise quality, you have to hire expertise, or you get consultants in, or you do some architecting or whatever, but you can get started, and you can fool around for next to nothing. And you can actually blend that. You can blend what you pay for and what you do for free very, very fluidly. So that's why Linux won. Now, if, as I said, the most mature e-commerce technologies are open source, and enterprise prefers open source in its platforms, and private clouds are the next platform for enterprise IT, the private cloud is going to be open source. It may not be Eucalyptus. God, I hope it is. But if it isn't, it's okay. It's going to be open source. QED. And perhaps we can see evidence of that. That is a Google mashup of Eucalyptus starts last year. More than 25,000, as David Butler, our VP of Marketing, is wont to repeat endlessly in my sleep. And the only continent where it hasn't started is Antarctica. And I'm working on that. But basically, we can tell very accidentally when if you download an image to run in your Eucalyptus system, we can tell where you're running a Eucalyptus system. And the thing to look at here is this stuff, right? I mean, Hawaii, sure, but the Azores? Isn't this in the Azores? So really, if you're looking for whether open source has uptake, if you're looking to see whether that viral experience is occurring, this is IT software, right? This isn't, an iPhone app. So we think actually that the thesis that open source will win and that Eucalyptus may be the catalyst is true. And if you want to start all of this, it's actually fairly easy. We have the RightScale My Cloud thing, which has been announced. It's fantastic. We also have, that goes along with it, Eucalyptus Fast Start. We put the stuff necessary to get this going on a memory stick. We also have it downloadable from our website. And then the Eucalyptus Admin Console, this is actually a screenshot of what comes up when you go to the credentials thing, has a registration button for RightScale. So it's already integrated, ready to go, memory stick deployable. Now I'll end by saying we are privilege to be working with RightScale. We've worked with them from the beginning of the project at the university. They've been fantastic supporters of ours, both personally and professionally. I absolutely encourage you to look at this as the technology that you build your business around, and we would love it if you would use Eucalyptus as part of that. I'll stop there and take any questions if you have.